In this lecture I'm going to show you to configure an IPv6 default route. And the same idea as with a static route for IPv4 addressing works with IPv6. You select a router and you select a default. You configure a default route in packets that where there's no destination in the routing table will then use the default route. So this example, there's three routers interconnected. Router 1 has a switch connected, and so does router 2. Then there's an ISP. This is the router at the top here, and that's the address of the router. The first four groups is the prefix or subnet, and the 2 is the host identifier. And it's connected to router 3. So what I want to do is I'm going to configure router 3, and what I'm going to do is I'm going to put a default route on router 3 so the packets go to the ISP. And I'm also going to add another command so that router 3 advertises that same default route to router 1 and router 2. So instead of configure them all, and router 1 and router 2 will then put that default route in its routing table and use the same default route to send packets to the ISP router. So the first thing, go to router 3, enable, and sign on. So it's quite easy to do. There's only a couple of commands to do here. The first one is I need to configure a default route, and that is a global command. So I'm just going to put IPv6 route, and then 2 colons, and then /0. And that's similar to the default route where I'm using a bunch of zeros with the IPv4 default route. It's kind of the equivalent. It says send all packets to 7.2. And 2001 DB8 3C47 and 2, that is the FA00 interface on the service provider router, the inside interface. So that's configured. That's the default route configured. Next thing I want to do is I want to go to this is configured with OSPF, so I want to go IPv6 router OSPF1. So it is running an OSPF version that supports IPv6. And then I want to add a command, default information originate. And what that does is that sends that default route to all routers connected to router 3. So in this case, router 3 has 2 connections. It'll send that default route from 00 and 01 to those connected routers. So now that that's updated, I'm just going to fast forward for network convergence so that it is advertised to both those routers. Now I'll go to router 1, and it shows here. This is showing that there is OSPF neighbor adjacency, so that tells me that's already occurred. So they are OSPF neighbors. They have to do that because this is actually an OSPF route, the default route, advertised through OSPF. So look at the table. Next thing we want to do. So there's connected routes and the associated local route for that connected route. It's just a host address. There's OSPF there. So what I've got here, and at the top there is my default route, this one at the top here. So the default route is going to go out 00. So it's just going to use the link local. It's just a local subnet interface there, 00. So it's going to send all default routes out 00. So there's 00 there. It's going to advertise it, or it was advertised there. So the packets, the default route tells the packets to exit 00. The same thing with router 2, it would be 01. So it's really an exit interface. So show IPv6 route. In this case it's the same thing. It's just using 01 this time. So that's just the default route. And you notice that there's no route to 7 subnet here or router 1, so it's going to use that default route because there's only in this case there's a route to 1, 2, 3, and 5, and that's it. There's no route to 7. Same with router 1. So now what I'll do is I'll just run a ping. I'll ping 7.2. And there it works fine. So it's using that default route, all 5 cent. And the same thing here, I'll go over and just do a ping. And it works fine, 100%. So it's pinging that 7.2 interface there from here and here. I can do a trace route as well. So we'll just trace route over to that address. And so from router 1 it's taking 1, 2 and then 7.2. So it's going directly here and then over to the ISP. And that is IPv6 default route.